Hello and welcome everybody to today's webinar. Today we have Tino Feenle together with us here. He's the product manager of the Open Telekom Cloud, and he will tell us today something about the Dedicated WAF. This is a new service and is the perfect service to protect your web applications, as you can see it here on the first slide already. With this, I would lead over to you, Tino. Thank you for having you here, and let's have a good webinar.
Good morning, everybody, also from my side. Like introduced, my name is Tino. I'm the product manager for the Open Telekom Cloud Security Services. And today's session is about Dedicated WAF as a new service to protect your web applications. So what is the agenda for today? First of all, I will give you an overview about the WAF itself, then some short introduction about the protection features the WAF offers, then the type of WAFs, because the dedicated WAF is a new type compared to the already existing one. Then I will give you a short demo of setting up from an empty and a web server, a load balancer, and the WAF, put on some simulated attacks to explore the dashboard and see how it works. Lastly, I will give you an overview about our general vision and roadmap for the security services and how the WAF plays into it and what new services are there to come in the future. So I would say let's start with the overview of the WAF at the first point. So the WAF is our web application firewall. What does it do? Basically, it protects your web apps, so like e-commerce sites, portals, or apps. So web apps you have against the common attacks and vulnerabilities. So it does this by analyzing the traffic and protects against the malicious traffic to your website. Why do you need it? Because basically also attackers like your web apps. That means a lot of breaches, almost half of them involved the web application as a attack in 2020. This has risen time over time. So even today, like 80% or more is the main attack vector for hacking actions. And one important point also is the price. So when you get hacked, it is not always a cheap one. It depends on reputational damage, but also damage for your data, your customer. So breaches have also price tags. They are rising time over time. So it is of utmost importance to protect your web applications, especially if you have, for example, important customer data or privacy data, company data to protect. That's where our WAF comes into play. Let me shortly give you an overview about the highlights we have. So first of all, the web application firewall has an automated attack detection and block functionality. It provides a management dashboard where you can see all alerts and you can control the policies. For policies, we have, of course, also custom policies, so you can implement them for specific use cases, like I will show later. It supports you in mitigating the top threats of the OWASP. It also provides virtual patching, and it is pay per use, so you pay per hour. Talking about virtual patching, I want to quickly explain what this means. So if you are in a classic environment and you have a new vulnerability coming up to the right, let's say, the average time to have it fixed and implemented in your own web server or web firewall is about 200 days. You see here now a timeline. So once you discover it and until your web applications are protected, a long time goes, because you need to develop a fix and implement it in every single web application or web server. When you use virtual patching on OTC, that means once a vulnerability is discovered, we patch the firewall in the backend. And this is also much faster because we have more resources, more personnel in the backend to do so. And your web applications are protected earlier. Advantage, of course, is for you, it's without additional costs. There is no downtime, no maintenance window. So you can just directly focus on your core business and leave the rest to us, and your web applications then are protected. What is the structure of the service? Basically, you see here on this structure that you have on the left the participants wanting to access your web server. On the top, you see the user. It wants to request the web service. It goes through the WAF, and you can access your web service. Then we have, for example, malicious competitors and hacker. that want to crawl your website or attack it, and this traffic will then be blocked. Crawler is one difference. You can also enable crawling that you are listed, for example, on Google search results, but you could also block that. The web application is one part of our portfolio for being a gatekeeper at your borderline. We also offer anti-DDoS as a free of charge service for your elastic IPs, and with that one, you have a good combination or perfect combination to protect your workload. So WAF is also integrated in our architecture. Let's come to the next point. These are the protection features we offer. Before I go into that, let me quickly explain how it works. Basically, once, for example, one attacker wants to attack your website. In this example, it's an SQL injection. You see the code like /login PHP and ID equals 5 or 101 equals 1. This is a simple SQL attack. Once it reaches the WAF, you have multiple levels of protection. The first one is so-called regular action. Therefore, we have some signatures and protocols which are compared to the request. When it matches, this request is blocked. For SQL injection, this is not possible because there are basically endless possibilities. You could also write ID 6 equals 1. Therefore, we have the next one. This is a semantic engine, and this one detects SQL injection or cross-site scripting attacks based on the semantics. And in the second step, this request would now be blocked and would not even reach your web server when you enable the block policy. That means you have then the built-in detection process, and there's also no user intervention from your side required. So then let's come to the protection features. We have 10 key features which I explain. The last 3 are dedicated to the dedicated WAF only. They will not apply to the already existing web application firewall. So let's start with the basic one. It's the basic web application, web protection. This is really like the name suggests, a basic web protection against the common attacks like SQL injections, cross-site scripting, for crawlers, for web shell, buffer overflow. So these are really the basic things you should enable, or which are also then enabled on default to protect against the common attack patterns. When you open the WAF on the console, it looks like this. So you have multiple options. The first one is the general check, then also for web shell detection, deep inspection, and header inspection. Compared to the already existing WAF, what is new is now the topic about known attack source. That means you can create a policy, for example, to long-term block IP addresses. This means, for example, once an attacker has been blocked from one of these attacks, you can directly block his IP address or the cookie for, let's say, for 10 minutes. That this long-term attack will directly blocked. Important to know, we have log only and block as a mode. Once you create a new instance or a new policy, it starts with log only, that you already see what would happen, but there is no impact in the start. We also have different protection levels. They are controlling how the semantic engine, like I explained, will behave. So coming from low protection level to medium, this also comes into the play about a trade-off between usability and security. So the higher the protection level is, the more requests will be blocked, but it could also be that false positives are occurring. Let's come to the next one. This is a challenge collapse attack protection, also CC attack protection. This is blocking basically spamming on your web server. For example, in this picture, you can see a lot of packages are disguised as valid HTTP package. They are basically flooding your web server, and when they arrive at the WAF, you can control how this is behaving. Starting with this policy, you can select what should happen, like per IP address, per cookie, and so on, and limit what should happen. One example page or a policy would be once you have a high rate of people accessing your web page, you want to, for example, require a verification code like a captcha. that they need to enter to justify or to prove that they are human. When you set this up, for example, this is on the top you see the standard blocking page, meaning the request is just blocked and there's nothing you can do as a user. On the bottom, then you can see, for example, what I said with the rate limitation, that you have a verification code which needs to be entered. The next thing is precise protection. This gives the possibility with the user data field to control basically what should happen with the request. For example, you can block or allow different devices, operating systems, browsers, IPs based on the user data field, also for specific times or specific websites. Here's just one example where I have a specific use case, like you want to block access, for example, for iPhone systems or iPhone OS operating systems on your web page. So you can modify this based on any fields and what content they should have, depending on the use case you have. The next thing is the web tamper protection. This basically is a functionality to cache the content of your web page. That means you can enter here the path of the static web page. It will be then cached on the WAF, meaning whenever a request is coming to the WAF, the cache will be responded to the customer. That has the benefit of more speed. So the web server does not need to be contacted, and also if there is any tampering on your web server, this would not affect the cached web page. Let's come to the next one. This is a black and white list. That's really easy. One, let's say you can just enter any IP addresses or IP ranges to whitelist. That means they will bypass any policies and always be allowed. And for blacklist, of course, they will be directly blocked. Then let's come to the new ones for the dedicated WAF. The first one is the geolocation access controls. That means you can block access to specific countries. For example, here's just Russia as an example, where you can block directly access coming from IP addresses from this country. And you have a lot of countries to choose from. You can also enter like allow, meaning all access from this location will be directly allowed, bypassing policies, blocked, and log only just to see in the logs when access from these countries are happening. As the next one, we have the information leakage prevention. This has two use cases. First of one, it's to mark sensitive information like an ID card, the phone number, or an email. Below, we can see an example like there are then just stars to filter it out. Secondly, you can also intercept the response code like 404, 401, like not found, not authorized, that these pages will not be returned to the customer. The last one is the anti-crawler detection, JavaScript anti-crawler detection. Basically, this is a method to block crawlers. They basically send some kind of information to the WAF, and usually the WAF would return this piece of script content to the client, and therefore the crawler would then have the content of the page, like to download all images from your web page, for example. With this anti-crawler function, you could then directly block this, meaning you won't also not be listed on any indexes like the Google bot, for example. These protection features then are all grouped in one policy. When you then create this policy, you can see on the screen they are basically have a green light when they are configured. Then are specified, so all features are specified in one policy, and the policy can then be assigned to a website or a domain, and you can also have then multiple policies on one domain. When you structure this one in a picture, then you can see below you have the WAF itself. There you have your dashboard, you have then the events, you have your logging. On top on that, you have then the domain and or website, where you have the certificates for your website and the protocols. Above that, then you have the policy. The policy can be assigned to one or multiple domains, and then above one you have the rules attached or included in the policy. That's how the structure of the elements are grouped together. Then let's come to the next topic. It's the WAF types. Like I said, this event is about the dedicated WAF. So we already have an existing one. We call it the shared WAF. And I just want to briefly explain what are the differences between them and how do they work. With that one, I just use a simple example about accessing the web server. It's just a really, really simple structure. Yeah, like you have your client in the internet who wants to access the web page. Yeah, he's answering whoisexample.com. Therefore, he sends this request to the DNS server. The DNS server is answering with the public IP address of your web server. And then basically you are contacting your web server. If you use the existing shared WAF, you protect your web server by creating a CNAME record to your DNS, sending the traffic, or no, not the traffic, but sending the reply of example.com not to your IP address of your web server, but to a domain which we are owning. It's a cryptic domain .otcwaf.com, meaning the client will then go to the WAF. The WAF is doing the protection, and then afterwards the traffic is forwarded to the web server. This is the traffic of the existing shared WAF. And with new dedicated WAF, it's a bit different. So let's come again to the example we have. Yeah, we ask our DNS server. It is replying with the public IP address, and we're going to the web server like we had before. What's now changing is with the dedicated WAF. First of all, we need elastic load balancer. The elastic load balancer is now internet facing. It has an elastic IP, so a public IP address. And now we need to enter an A record to the DNS pointing from the IP address, the public IP address of your elastic load balancer to the domain. That means the client is then going to your elastic load balancer, and the load balancer is forwarding the traffic to your WAF. One advantage, like you see already for the IP addresses, is the WAF itself is not in the public internet anymore, and also the web server not. Then you have the possibility to route the traffic to the elastic load balancer, to another one, which could also route the traffic to multiple web servers behind. Or if you don't need it because you only have one web server, you can directly route the traffic from the web application firewall to the web server, who is also now an internal IP address. So having this overview again, what are the advantages of the dedicated WAF? Like I said, you have the integration with the ELB. So the ELB is then the internet-facing component. The WAF instance and also the web server is not facing the internet anymore. Also, you have the possibility for high availability, so you can also deploy multiple WAF instances on different availability zones. And also there are the single point then of failure, meaning you are also advised to provide multiple instances because they are then tied to one availability zone. Like I introduced before, the advantages are also three new features like the geolocation access control, the anti-crawler, and the information leakage prevention. So these features are dedicated for the new WAF type. If we bring this overview together in some kind of table, here you can see again what are the difference between them. So the shared WAF is a shared hardware. For the dedicated one, you get a dedicated virtual appliance, which is available in 2 flavors. The shared WAF outside your VPC, so it cannot be integrated into the ELB, and you need to set up a CNAME record. For the dedicated WAF, it's inside the VPC. It requires an ELB, and you use the A record for the ELB IP. For the security, for the encryption, it has also the benefit. The dedicated WAF is using the ELB beforehand. So, for example, if you would set an ELB certificate requirement to require also a security policy require TLS 1.3, you would also enforce it before it reaches your web server. For the feature set, it has the same as the shared WAF, like I explained, but the 3 new ones. The billing is a bit different. So for the shared WAF, you pay per domain and also per requests in millions. For the dedicated WAF now, you pay only the instance per hour. So it doesn't matter if you have now 3 or 300 web pages or domain, you just pay per instances. So it is also useful if you have multiple websites. For the capacity, The shared WAF supports traffic peaks up to 300 Mbits and about 10,000 queries per second. The dedicated WAF has two flavors. Let's call it a small one with 100 Mbits and 2,000 queries per second maximum capacity, and a bigger one with 500 Mbits and 10,000 queries per second capacity. So on the next part, we will go into a demo. So what we want to do is to set up an environment and show you how you can quickly set it up. What we do for it is to create an architecture. You can see on the right the target architecture we want to achieve. Basically, we have the client who will access then firstly the ELB. The traffic should be forwarded to the WAF instance and then later on to the web server. We do so by setting up the VPC or subnet, then ELB, the WAF itself, a web server. Then we do the DNS setup and also attack simulation. So then I would say, let's start with the first one. Like I mentioned, we need to start with the VPC because the ELB, the web server, and the dedicated WAF need to be placed here. What do we do? So first of all, we create a dedicated ELB. We need to enable IP backend. That's a new feature to be able to enter the IP address of the WAF in the ELB for traffic forwarding. Then we use the VPC we created, or we create a new one, and we need to choose the application load balancing. And we can also already directly add a certificate for ELB if we want to use HTTPS. So let me switch to the console. So we are now here logged in on the homepage on the OTC. Let me just reload it. We are still logged in. So we start with the ELB. So we go to network, elastic load balancing. Then we create an elastic load balancer. We choose the dedicated one, and I use the project I just created for that. And like I said, we need to enable IP as a backend. Here I already have a VPC. If you don't have one, you can create a VPC here, then a new tab opens and you can create one. We just use a new EIP and we choose a small one for application load balancing. We just give it a name and then create now. Here you can see an overview about what will be created, and we click on submit. Basically, that's a really easy step to create the ELB. In this example, we just use HTTP. If you would use HTTPS, you can also then upload your certificates and configure the TLS security for your website. So that's basically the step one. If we then look in our architecture diagram, we just have the ELB here, nothing more. It has a public IP address. So if we go back to our ELB, we already see here the public IP address, which we need later. Then let's continue. The next step would be to create the dedicated WAF instance. Therefore, we will also go into the console. Important is to select the VPC, that they are on the same VPC, and to also have a security group allowing port 80 or 443, depending on HTTP and HTTPS, allowing access to the WAF instance. So we go again into the console. Then we go now here into Web Application Firewall Dedicated. And then to create one, once we open it, we directly have here apply for dedicated engine. So we click on here, give it a name like WAF demo. I select just a small one and select the VPC. And I also select the security group allow me access. Here again, you can see the picture about how the architecture works. Then I click on Create Now. I get again the overview. Click on Create Now, and it says it's in creation. If you go now to the list for dedicated engine, you can now see your WAF instance here. It is basically still empty because it's in creation. You see here running status creating. This will take a few minutes to create your instance. So we have created this one, or basically it is in creation, meaning if we now go to our overview, we have the ELB and we have the WAF instance, which is in creation. You already see the WAF instance has a private IP address, which we will need later. As a next step is then creating a web server to have one example overview where we can send the request to. What I will use here is a simple web server from Uli's hands-on. This is a series of hands-on trainings or overviews. There is a perfectly usable script for setting up a sample web server, which we will use. We will also place the ECS in the same VPC, and we also assign it the security group allowing access to port 8443. Once it's done, we also check the EIP just to see if the web page is accessible. Of course, later on, we won't need it anymore. So again, we go into our console, then we go here into Elastic Cloud Server and create ECS. I will just use a bigger one that it's created more quicker. I select an Ubuntu, just the latest version, configure the network. Here I select the created VPC and also the security group. I choose auto assign an EIP that I can access it from the internet. Firstly, just to check it, I need to select a key pair, but we don't use it because we don't log into the machine. And what's important now is for advanced option to click on configure now. When we now go into Uli's hands-on training, there's this B09 ECS Linux with a simple web server. Here it's explained again how to set it up. But in this example, we just need this script. So we can download it and open it. And basically that is the content we need to copy and need to paste here. Click on confirm and then create it. Basically, that is now creating the ECS here with this script. This script is basically installing a web server, downloading from Uli's bucket sample web page and unzipping it. As you can see, the ECS is creating here. If you click here on refresh, we already get the private IP. It's on running. What we can do is we can go in the machine itself, and if you go on console logs, you can basically see what's happening. If you click on query, you can see, okay, this one is still in creation, so it's doing the initial cloud init job. And every few seconds you can query again to see what's happening. Basically, this machine is now being created. When you go to the machine and click on update, you can see, okay, we directly have the EIP that we will copy because we will just check if access to the web server is working. Before we do that, I still check again if it's done. Cloud init, it's still working, so we need to wait a few seconds that the script is working, downloading. Here's some packages, and then later on downloading the website from the bucket, extract it, and then we should be able to access it. Let's check if we already can access it. Yes, so now it's done. This is the EIP from the web server, displaying the time and the IP address, just as a simple web page that you directly can see. Okay, the server itself, it's running. Going back into our overview, what did we do now? We have now 3 components. We have the ELB, we have the one WAF instance, which is hopefully created until now, and we have the web server itself. What you can see here is now there are now no errors to the components, because basically they're just loosely lying around in the VPC and they don't talk to each other. What we need to do now is setting up the connection between them. What we need to do is, first of all, we need to configure the Elastic Load Balancer. We need to add a listener and create a backend group where we can add the IP address of the dedicated WAF. We also need to enter the health check. So we need to check the health of the WAF. There's a HTTP health check, which we need to change to port 80 because we use HTTP. As the next one, we need to configure the dedicated WAF. So we need to set up a website and basically tell the WAF to forward the traffic to the internal IP address of the web server. If you would use HTTPS, then we also would need to add the certificates, and then we need also to check if the flow, let's say, is working. So what we need to do is, again, we go into our console, and next thing I go to the dedicated WAF, because I need to know the IP address of the dedicated WAF. I go into instance, dedicated engine, and I see it's now running, so it has been created, and this one is the IP address of the dedicated WAF, which I will need. So basically, I now go to Elastic Load Balancing. I choose my created ELB. I go to listener. I add one. I choose, or I stay with port 80. Here it's also port 80. I create a new backend server group. And for that one, I need to choose IP as a backend server group, enter the IP address of my WAF, port 80 for HTTP. And for the head check, I also need to change to TCP and port 80. Then I click on confirm. And now the backend listener has been created. Basically, that means whenever traffic from HTTP, so port 80, is coming, forward it to the server group, and the server group is then basically the dedicated WAF. It's then listed here as IP as backend server. This is currently on unhealthy. It takes a while that the traffic is then, or if that the health check basically is working. What we can do as a next step already is go to the dedicated WAF, go to website settings to add the new website we have created. So what we need here is then also the IP address of the ECS, because we need to forward the traffic from the ELB, which arrives at the WAF, to the web server. So what we can do already is, here's the ECS created. We can copy the private IP address of the ECS. Then we go into the website settings, add a new website. I just give it a name like demo IP. And I need the protected object. This one will be the public IP address of the load balancer. And for the server configuration, that would be the private IP address of the server, which I paste here. For the protected object, I need the load balancer's public IP, which I can copy here and enter it here. Basically, now we are protecting the public IP address from the ELB as an object. And the origin server where the traffic should be forwarded to is the IP address of the web server. Then we click on confirm. And now we have the website settings for this website. What we can directly check is for the ELB, if we now go into it. And for the backend server groups, we have still the IP address of the WAF. It's now healthy. That means also the connection between the ELB and the WAF is now established. What we can now do already is copying the public IP address of the ELB, because what we now want to do is we don't want to access the web server directly via the public IP address of the web server. What we want to do is access the IP of the ELB. Ideally, that is working, can take a few seconds. That's working. Let me check it later. That we have the access directly over the ELB. Meaning, if we go to our overview, how should it look like? The access is now from the client to the ELB, which has a public IP address, who is forwarding the traffic to the WAF instance, and then the WAF instance is forwarding the traffic to the web server with the private IP address. Once this is working, we can already then detach the EIP of the web server, because usually we would not need it anymore for the web traffic. It could be that we enable it, but only limit access to administrators if there is the need to access the web server directly through the internet. So let us check again and update. It's still bad gateway, but it will work later. The next thing is basically what we have done now is doing everything on IP address level. That means you need to know which IP you would want to access. The next step would be a DNS setup. That means, you don't want to we remember the IP address. You want to access directly the name of your website, let's say. Therefore, what you want to do as the next step is you want to add an A record on the DNS for the external IP address of your ELB. And what you then need to do is also create a new website with the DNS object as a protected object for your WAF instance. So basically, that is the next step we want to do. For this step, it depends on where you administrate your DNS. In our example, we administrate the DNS on OTC. Therefore, we go back again in the console. Let me go to the home page. And we also have here DNS. We have a borrowed domain from Uli. It's Uli's hands-on DE. This one is basically currently empty. What we now want to do is to basically provide an A record, and we can just for example choose one domain we want to use. For example, just waf.ulishands-on.de. What we now need to know is the IP address of the ELB. That is the public IP address of the ELB, which we need to enter here. And basically, that is the step we need to do. There's nothing more additionally, because the traffic itself should already directly work via DNS once it's synchronized. So how does it work? Yeah, instead of asking, so we ask our DNS server, who's ulishands-on.com, and then the DNS server basically is responding with the IP address. We do not need to remember the IP address anymore, meaning if we now go to waf.ulishands.com, we can then access the web page directly with the name. The next step is we want to see a bit more into what happens, how do I use the console. So basically, if you go into the console today or now on the dedicated WAF, it's basically a bit empty. So we now go here and the dashboard is empty, and we see only the request to the website itself. What we want to see a bit more. Like I said, first of all, we need to create a website with the name. So I call it demo DNS, and we now enter for the protected object the domain. And again, we have the web server. Here's the private IP. Meaning that also then we protect the domain name itself. To test your WAF or to put some entries into the dashboard to see the events and what's happening, what you can do is you can open some or use some third-party tools. In this example, I use Wafer. It's from CloudBix, a tester. So I can copy the domain name here and let it test. waf.ulishands-on.com. Click on evaluate. What I need to do to see some examples is to identify myself. So I click here on other, and then I need to set a DNS record to prove that I'm the domain owner. So this is the TXT record I need to create to prove that. Therefore, I go again to DNS and to my DNS zone, and I create now a text record because that is required for cloudbix.waf.ulishands-on.com, and I choose this value. I copy it, paste it into the DNS that I am authorized to access, or that I'm proving that this is my web page. Basically, what you can then do once it's checked, you can send out some example requests. So this is simulating SQL injection, cross-site scripting, and so on. Once this is done, you can then see in your overview on the dashboard some examples. So you see then here, for example, the cross-site scripting events, the SQL injections, and so on. When you click on events, you can then also see the event itself and can dive into the event to see what's happening. Basically, this is then a bit similar with the shared WAF, but only the dashboard shows a bit more graphical difference. For the events, it's basically the same. So we can look into the events, you can open them, then you can see the malicious payload, and you can also see the action like that it is blocked. Basically, that's also concluding then the demo of the WAF to show how to set it up and how to use it basically in real life. Coming to our last point on the agenda, I quickly want to talk about our vision and roadmap. So what do we do at the security services and what do we plan for the future? First of all, let me give you an overview about what we have today. What we have today for services are, first of all, the broadly used or necessary service IAM. So that one is for managing identities and permissions. The next one is KMS, the key management services. With that one, you can encrypt data at rest. Finally, we have protection of workloads for the network side with anti-DDoS and the web application firewall, like I just showed today. What we want to achieve in the future, what is the vision, where do we want to go? We want to provide you a state-of-the-art cloud security center as a centralized platform for threat detection and alarm management. This means for the whole OTC, the aim is to provide a cloud security center. This cloud security center should then include all assets type we have, like compute, network, container, databases, assets, and also third-party integration. So like you would expect from other big cloud providers, you have one centralized platform and you see events from all assets type you have. That is the big goal we want to achieve. What do we do to do this? We implement, first of all, new services, which are then integrated in the Cloud Security Center. First of all, we just released a new service just a few days ago. It's called Database Security Service. That one is a new service to protect and audit your databases. What will come next is a service to protect your virtual machines and containers with host security service, which offers intrusion detection, some baseline checks, and also vulnerability management. And as a next step, then we want to provide protecting your network traffic with a service called Cloud Firewall, which is providing intrusion detection and prevention for north-south traffic, so from internet into your server, but also east-west traffic detection, so between VPCs. What is the plan to do that? If you follow our roadmap, we implemented anti-DDoS and WAF a few years ago. We implemented the dedicated WAF this year, and also the database security service just recently. The next aim is to provide the host security service, afterwards then the cloud firewall, and at the end the security dashboard to summarize all events and all findings of all security services in one central dashboard. This one is just a rough planning. What you can do to stay up to date is to go to our public roadmap. So this is published on our homepage. This is just an extract on our security services roadmap. This will change or will be updated every quarter. So this one is status from August this year. So like 3 weeks ago, where we planned database security services to take a bit longer to be released. Fortunately, we were quicker and released it just last week. So here you can see the plan. When do we want to release new services? You can also hover over it, and then you can see a rough summary what the service should do. And this is really your place to go if you want to see what happens on Open Telekom Cloud, not only for security, but generally because you can also see for compute, container, for basically all the services we have, what will come in the future. Basically, this is all also concluding then the roadmap and also all topics I had on the agenda for today. Therefore, I would say thank you for your attention. If you have any questions later on, you can just drop me an email, or also maybe ask a question in the OTC community, and then we are also happy to answer it.
Thank you a lot for joining us today. Thank you a lot to you, Tino, for presenting this nice webinar here. So thank you to everybody, and see you again in the next webinar hosted by the OTC Community Portal. Thank you a lot. Bye.
Thank you.